And if someone could hit the lights, we'll take them all off.
Do you want the hand mic?
Yes. Oh, yes, I'll take the hand. Okay. We're on? Yes, we are. Okay. Fasten your seatbelts, because this is going to go pretty fast. I will skip over even some slides because there's limited time. But I'm using this program done by Bob Lindmeyer, who is a climatologist, meteorologist at a TV station in Madison. So a lot of this program is going to show you the effects in Wisconsin and Madison specifically, but we're not too far away from Madison, so I thought this would be a good way to go. Now, if I'm doing it right here. No, I went the
Yeah,
wrong
that's
way.
a blank.
I went the wrong way. Thank you. The view from the space shuttle. Oh, okay,
Yeah, you
I'll
went
get
the
it right
wrong way.
here. Yeah. What's happening? Sorry.
I did that. But yours is working because I didn't do that.
Okay, here, we'll get it. Now I'll do this. Got it. Now I got it. Sorry. Okay, astronaut Piers Sellers made this observation. You get up there and the Earth is this huge ball. And when you look at the horizon, there's this tiny film of gas around it. It's just a thin blue ribbon. It's the atmosphere. I mean, there's almost nothing there. Now, in terms of climate change, there is no dispute, and probably everybody in this crowd would probably agree with that, but I am just going to update you on the latest facts. First of all, it is real, it's us, there's no question about that. Things have happened in the past to cause extinctions with volcanoes, asteroids, etc., but this we're doing to ourselves, which is what's really pathetic. It's dangerous, it'll cause our extinction if we're not careful. Scientists all agree, and I'll come back to that in a second, and we do have solutions which can at least mitigate the consequences. So they say 97% of climate scientists have concluded that it's happening. Actually, when they've done the looking at the actual research out there with scientists who are actually working on it, it's 100%. So the 97 is no longer acceptable. And they've known about this for a long time. As soon as we had the instruments to measure CO2 and we began the Industrial Revolution pulling coal out, Joseph Fourier, a Frenchman, theorized that yes, we were going to have problems down the road with the carbon dioxide buildup. And these are the real important scientists through time, all the way up to Keeling, who did research in Hawaii, who have had a big impact on the climate science. Just so we're on the same page so you understand exactly the greenhouse effect, the sun energy comes and warms the earth. And some of that escapes back into space. Let's see if I can operate so right here we've got it reflecting out. And some is held in the atmosphere, which we do need, because if you'll notice on the left there, Earth is about 60 degrees Fahrenheit. Without that atmosphere, we'd be at zero. We'd be a cold planet. The greenhouse gases, our atmosphere is 99% nitrogen and oxygen. And we have some trace elements that keep us warm, that hold the infrared energy. Water vapor, carbon dioxide, which you're familiar with, methane, you're probably fairly familiar with, produced by the animals mostly, like cows and creatures like that, and nitrous oxide, which is laughing gas. And that's produced naturally, but it's also produced a lot by our agriculture when we use nitrogen fertilizers. Oh, did I hit the wrong thing again? Yeah. Okay, the problem with the greenhouse gases is they last a long time. Methane will break down in 10 years and it traps heat very effectively, but it breaks down into carbon dioxide, so it's still up there. Nitrous oxide takes 100 years to break down, and it's the best heat-trapping gas out there. One molecule of nitrous oxide will trap 300 times more heat than carbon dioxide molecule. So it's really the more dangerous one, and it's again produced mainly by our agriculture. And carbon dioxide, you're familiar, but it does take 1,000 years for it to dissipate. And that means what we've built up so far will eventually disappear if we stop burning fossil fuels, but it'll take a while. So we have an example next door to us, Venus. They've sent probes out to Venus, so we've made measurements, so we know what's in the Venus atmosphere. And Venus has 200,000 times more carbon dioxide than the Earth. And as a result, the surface temperature is 880 degrees Fahrenheit. It's not livable, obviously, for us. And the Earth, if we don't have too much carbon dioxide, we average about 59, 60 degrees Fahrenheit. So how have we measured CO2? And they always talk about how it's built up. Well, how do you know what happened in the past? Well, the main method is ice cores taken from glaciers. We also do the ring patterns showing where tree stress occurred on weather patterns. Also, the coral shells have bands that will reflect changes in temperature. And the sediment cores that reveal the ocean chemistry. And what's interesting about the air bubbles trapped in glacial ice is it's very simple. They melt the core down and then they measure. They capture the gas as it's melted out, and they can measure exactly how much carbon dioxide occurred 800,000 years ago. So they have the data. So what's happened? In fact, on this graph, they show it going back to 800,000 years. So our red line is the carbon dioxide. And of course it fluctuates, goes up and down. We've got ice ages, we've got volcanic activity causing previous extinctions. And if you look over to the right, you'll see the word now. Well, actually, where it comes down to that low point, it's about the start of the Industrial Revolution, because of course we really telescope time on this chart. And you'll notice how fast it's gone up. In the past, we very seldom went beyond 300 parts per million. And of course now we're way above that. And that graph is for 2018. The new high for CO2 happened so far in May of 2019. We were up at 415 parts per million. And right now in October, we are back down to 406 or 7. Now you'll notice it fluctuates, and that's because of our growing season. Now you may wonder, well, what about the southern hemisphere? It has summer when we have winter. But most of the world landmass is in the northern hemisphere. That's why you see the greatest effect when the northern part of our world is, or at least what we call the northern part, is in its growing season. So what have we got for nitrous oxide? That's the green. Way back in the year 1000, yes, we had nitrous oxide because bacteria in the soil breaks down nitrogen and then it gives off that nitrous oxide. So we've always had some. It's just that now we have a lot more. And then we have methane, and we've always had methane, a little less. And again, that's mainly being caused by agriculture, livestock, and fracking. Fracking gives off a big amount. And then, of course, carbon dioxide from all our burning of our fossil fuels. Now, it's very interesting, this graph here, because temperature fluctuates. We're going back to 1880 on this, where we've had definite records that we could depend on. And of course it goes up and down. We have hot years, we have cool years, and it depends on a number of factors, volcanic activity, etc. But in terms of carbon dioxide, we've steadily increased, and this is the average. And that line is fairly steady. The other line, which fluctuates, if you took the average temperature all the way through, it almost parallels the rise of carbon dioxide. And right now, we're already above 1 degree centigrade increase over time. And you may think, well, that doesn't sound like much. That's about 2 degrees Fahrenheit. But as we keep increasing, again, we're seeing the effects of that. And that's about where 2018 comes. And if you look at all those years where we've got high points, Those are all within recent years, not talking back at 18 something. Oops. And our hottest years on record globally, 2018, you'll notice, was the fourth warmest. 2016 was the hottest year. However, we're thinking probably 2019 is going to take that record away. But we'll see when the year finishes. But it's all within recent history, 2014, 18, 17, 15, and 16. And these show where we have records. You'll notice on the U.S. that the area around our area, South Dakota, Canada, etc., is a little less, or near average. And there are a few places that had a little colder, but overall it's a rather pink-red map. Okay, I think we move to the
end
next.
of that one.
Yeah, now we're going to look at the consequences. She just has to switch to the other one.
I think that's it.
That's the first one.
Is it?
That's the science one I just did.
Okay, you're right.
Yeah, it should say consequences. Yeah, that one.
Yeah, but when I go to the, oh, I see the problem. I see the problem.
Ah, there we go. Okay, thank you. Okay, so we have a number of consequences. I think you're all familiar with this, so I'm not going to spend time on those. But again, these have all had effects that are slowly just compounding and increasing. And the global assessment report that came out with the UN covered in greater detail. We don't have the time to go into this, but if you'd like to see this particular chart at the end, I could put it back on the screen. So now, over time, from 1910 to 2018, we have more extreme weather. And this, again, the white bar is the average, again, because it has fluctuations. And in terms of federally declared disasters, we've had a big increase. If you look back at 1980, yes, we had 2, 3, 4, up and down a little bit, but in the most recent years, we've had more and more of these. And these are the big billion-dollar ones, not even the ones that are just million-dollar stuff. And again, you'll see that the most recent ones, again, the highest numbers are the recent years. And I think I'll skip that one. Now, biggest tornado outbreaks too. Back in 1950, we've always had some tornadoes. That's not a new thing, but it keeps increasing. And again, this chart goes up to 2017. And we have more downpours, so there's an increase in the heaviest precipitation events. So if you look in the Midwest, we're getting 42% more. And more extreme rain, again, comparing from 1910 to 2018. So these are one-day precipitation. If you can remember back to our 2008 flood from Fond du Lac, where we got hammered. And there is a reason for that because of the jet stream weakening. Then systems stall out. They don't move through as fast, and so then you get one storm after another following like a railroad train. And how wet was 2018? Again, we haven't finished 2019, but you look at those records, look at the West Coast. There's hardly anything there. They're dealing more with drought, where we're getting hammered with the rain. And again, the jet stream is part of the reason for some of that. And here was, of course, they were, all concerned because 2018 was really, really high in water, but look at what's happening this year, and we've already broken the record just couple days ago. And comparing for Madison, we're going to zero in a little on Wisconsin. This is the change in days from 1950 to 2017, where we had heavy rainfall events. And daily deluge, again, this wettest day. And Madison had a really humdinger just a couple years ago. And Wisconsin's warming, Right now, we're 2.7 degrees warmer than we were back in 1970, and that's an average temperature. Now, warming at all levels, you can compare Madison, which just happened to be slightly ahead, the rest of Wisconsin, and then the U.S. Actually, the area around the Great Lakes is warming a little more in comparison with the other states of the continental part, not Alaska. That's a different category. The hottest years for U.S. cities. If you look back in 1920s and 30s, there were a few records that fell, and then we cooled off for a while. 1990s, we had a few records, and then when we hit the 2010s, we had big time breaking of records. Seasonal warming. Now, interestingly enough, winter is having the biggest, the whole thing is having the biggest impact on winter, but all of them have steadily increased in temperature. So our warming winter in Madison is now 4.8 degrees warmer. And again, we'd be pretty similar. So and extreme cold. You may remember when you were real young how we had some really cold spells going down to 20, 25 below. We might hit a little of that now, but not nearly what we used to experience. So it's 10 degrees warmer on the really cold end. So what's wrong with winter warming? Well, less snow, which doesn't help the farmers' fields. Also, it hurts winter businesses, or if you're a skier like me, the snow is quite unpredictable. Fruit trees blossom a little early. It increases the pollen, and we have more insects that survive that can carry diseases, specifically mosquitoes. Our spring warming, we have our average temperature now again in Madison is about 2 degrees warmer. And what's the impact on that? Well, it throws the timing off. The birds come back expecting insects. Well, the insects are waiting for, everything gets mistimed. So the insects might show up too early or they might start too late. And then they're looking for pollen and the plants might have already opened too early. So things are mistimed because they've all evolved together. And how does that impact us? Well, food. Our food is, at risk in all of this. Now our summers are getting hotter, about 2.2 degrees. And this increases pollen, asthma problems, and we have a longer, more severe season. Now, allergies, it's kind of interesting because we have more growing days now. We actually have 29.8 days where we have more allergy and growing season, but that doesn't help people. Some of you may have allergy problems. Well, you may notice that they're getting worse now. And disease danger days in Madison was about 19 more days. Again, this is from mosquitoes. Interestingly enough, researchers put a bunch of plants in CO2 to see what would happen with the plant, increase the amount of CO2, and they found that vines loved CO2. So that means you're going to have more poison ivy, kudzu, good luck down south with the kudzu, and it is creeping northward, by the way. It's in Illinois now. And we also, interestingly enough, they put ragweed, which is one of our big asthma-causing or allergy plants, and they put it in more CO2, and interestingly enough, it grew about 10% more, but even more important, it had 70% more pollen, which is just unbelievable. For some reason, that really stimulated pollen. Oh, now we're on the next one. Okay. So quick pause here. We'll be getting to solutions in a second here. Now we're moving to solution part. So I don't mean to depress you here, but just to let you know how important it is that we start taking some extreme measures to cut our emissions. Because you'll notice on here, we have the extreme emission cuts for 2010. Well, here in 2025 or 2020, if we start doing something serious about it, we'll keep the projection of the degree rising down. So we don't go above 2 degrees. But if we just same old, and keep on our little merry way, you'll notice the current path will, at 2010, will take us up where we're almost at, 5 degrees Celsius increase, which is bad, okay? Again, it may not sound like much. Now, climate hazards in Madison specifically, you'll notice that the red is if we do nothing. We just continue on our merry way. And if we start doing deep emission cuts, you'll notice how we draw back on the intensity. It doesn't mean the stuff is going to go away because the carbon dioxide is up there. But at least we're going to keep it from getting worse. We'll have more danger days with heat index above 105. Even this last summer, you can remember how we've had a rather humid, warm summer. And if we don't do much by 2100, our Madison, Wisconsin will be like as if you lived down in Louisiana. That's what it'll be like. So what can we do? Well, one, we have to replace fossil fuels with renewable energy. And of course, we're starting to work on that. I don't know if we're working fast enough, but it's happening, okay? Reduce our carbon footprint. We can all do as much as possible about that. And that's each of our responsibilities. And develop some adaptive strategies, because the carbon dioxide is up there and we're going to have consequences. So we have to be ready to deal with that. And we need to fulfill our international agreements. Because at least, it's affecting everybody. So now they've always talked about how we need to plant lots of trees. The problem today is you need to plant specific trees because our spruces are in trouble. Our ashes obviously are in trouble, but there are some hardy species out there, and I know people aren't real fond of box elder trees, which are a type of maple, but they're native and they're hardy and they grow a long time. They're a little messy, but they're a good tree. So please don't take out your box elders. I'm just putting a plug in there for them. They do remove your carbon dioxide, lower your cooling costs, and clean the air and water. And in Madison, they figure that each year, this is how much is removed of CO2, 2.5 million tons, just by the trees in Madison, or storm water runoff avoided, or air pollution absorbed. So specifically, things that we can do, obviously at home, put in solar panels, make our house as efficient as possible, new windows, whatever you have to do, so that you're cutting back on energy usage. On the road, well, I know we have some bikers in here, use your car as efficiently and as little as you can, walk some, which is actually good exercise, and the electric cars, which can make a difference. In fact, the more we all move in that direction, it will pay off. And finally, what you do with food, because food is a big driver of our problems in climate change. We waste 40% of our food in America today. Well, that meant we spent that energy growing it, doing all that, now we're just throwing it in the landfill or on your compost pile, but we've wasted energy. So try to be as food efficient as you can, and also skipping that burger. Again, unfortunately, the beef is probably the worst of the meats in terms of having impact on our climate. So cut back on meat as much as you can. And of course, it helps that we've got solar costs coming down because a number of things are happening that way. At least our church has panels up there, which is great. And now, in terms of renewable energy growth in Wisconsin, wind energy has probably seen the biggest increase, but we've increased 21% since 2001. And solar, of course, it's only from 2014, they're comparing it, but it's 52%. And we're starting to get some large-scale solar deployment. And we're looking at maybe getting one in Fond du Lac. We hope that pans out. We'll see what happens. And again, the emphasis from the UN is we have, last year this was, 12 years to cut our global emissions in half. And I'm sure we've made maybe a little progress, but again, now we're down to 11 years. Oops. Oh, so the solution that I'm going to put out, which comes from what Citizens Climate Lobby is especially working on, is if we want fewer emissions, we make them more expensive. And when we had a problem with fuel consumption and the economy tanked, our carbon dioxide actually went down because people weren't driving as much, as one example. So the best way to make them more expensive is to put a fee on the carbon when it comes out of the ground. And I'll go into the specifics here, as well as a dividend policy. And the particular one that they're putting out in Congress right now is called the Energy Innovation and Carbon Dividend Act. There are some other bills that have also been introduced, so we actually have them out there. The Senate has a couple versions, however, they haven't actually been introduced to the floor. This has some bipartisan support. The number is HR 763. I can remind you of that later if you want to fill out a form to Grothman today and urge his support. How this works, I'll explain each part of that. So the carbon fee is going to place a fee on coal, oil, gas, and it starts low. We start at $15 a metric ton. And then each year it goes up $10. So it slowly goes up, making it more and more expensive. And it is charged to the company or the distributor who brings out the particular fossil fuel. If they're bringing it out of the ground or out of wells, or they're importing it, say at the port where it comes from Saudi Arabia or someplace like that. That's where the fee gets paid. Then we go, what do we do with that money? Now we turn around, our suggestion is it goes back to the public. Everybody receives that money back as a dividend. The first year, 8% of it will have to be spent setting the program up. After that, there would be 2% fee just to run the program, sending out the dividends to everybody. The nice thing about this is everybody gets it. It doesn't matter if you're Bill Gates or you're some poor person on the next block. It'll make the biggest difference to the poor and middle income. And they know that at least 60% of those people, of all the US citizens, will be able to meet that change in prices. Okay, border carbon adjustment. Well, you may think, well, what about some country that isn't doing that? Well, if we're sending out something, we're exporting to a country that doesn't have a tax fee on, or a fee on the carbon, then that company will get a refund. Or, well, anyway, there's an adjustment, so it evens the playing field, but it's done at the border. There is limited regulatory adjustment. At first, they're going to wait, see if this does the trick. If after 10 years, the House one will then put out some regulatory authority and start putting some regulations into effect to make it happen. But they're going to wait for 10 years to see if the market just does it. In the Senate, they're going to do it after 6 years. And what are they finding out? Well, first of all, this is going to be very effective. They found from the REMI studies that 40% of emissions will be reduced within 12 years. Well, 40% is a nice amount. Now, that doesn't mean this is the only thing we have to do. This is a start process, and then we have to continue increasing clean energy and other things. But this is an important first step. And it's supported by economists and scientists, and other countries are already using it in some places. Canada is one, for example. This is good for people. It'll improve health, save lives by reducing the pollution that Americans breathe, and again, that dividend puts money back into people's pockets. So it actually helps our economy. It'll create jobs. They know that The green industry, clean energy, produces a lot more jobs than the fossil fuel industry does, as well as all those dividends will stimulate the economy. This should have bipartisan support. Of course, right now we've got a few Republicans, but mostly it's Democrats. But the thing is, we've got to keep emphasizing and reaching out to across the aisle because, frankly, Republicans' houses are going to get flooded as well as everybody else's. It's not a political problem. It's everybody's problem. Wonder why it does that sometimes. And solving climate change is just too urgent to get caught up in that, as I just mentioned. And again, the fact that this will be revenue neutral, so it should help the Americans to meet that. We shouldn't have the reaction they had in Paris with the yellow vests, where they suddenly put a higher tax on everything and people had no way to pay it. So what actions can you take right now? Well, you can write to Congress. I'll make it easy for you today. Down there by our Citizens Climate Lobby trifold, there are some forms there. You can put your name and address on there and write a couple sentences to Glenn Grothman about let's get going on this, or whatever you want to say. And I will deliver those to his office. So it can make it easy, save you a stamp even. And if you are a community leader, you can go online and endorse this Energy Innovation Act. And that's the website address that you would go to, energyinnovationact.org endorse. And you could join Citizens Climate Lobby. Now, just a couple quick words about our lobby. It's all volunteers. It's 10 years old now. We have just a few paid staff at the national level just to run the website and do the things that need to be done just to keep the thing organized. And there are 485 local chapters across our country. There are all sorts of chapters in Canada, Mexico. It's actually now all over the world. There are the most in our northern North America, but it has grown. And this is their, when they meet in June to lobby in Washington, D.C. So lobbying the Congress is the main thing they're going for right now. If they manage to pass the Energy Innovation Act, then they're going to move on to the next step. But again, we got to get this to happen first, and that's why they've stayed really focused on it. So finally, our main focus again is to keep this planet livable so that we survive. I mean, the planet will go on fine without us, which may end up happening, but we hope not. So anybody who would like to discuss this further or see a slide later after we've closed the service, I'd be happy to talk to you. Okay, so thank you.